Hi guys, today we are learning about the area of a regular polygon. First thing we have to talk about our vocab. The distance from the center of a polygon to any side is called the apothem. The distance from the center, so here's my center, to the side of the polygon would be called the apothem, so I'm going to label it with an A. The radius of a regular polygon is the distance from the center to a vertex. And I'm wondering, well, why is that? Well, if I drew an imaginary circle around my regular hexagon, we can see that the radius of that circle would be from the center going to any of the vertices. So we just automatically assume that's true for every single polygon because you can prove it by drawing an imaginary circle around the polygon. So let's label it with an R for radius. The last thing is we're going to use this formula to find the area of any regular polygon. You need to have 1/2 times the apothem times the perimeter of the polygon. So let's see that in action. Number 1, find the area of the regular polygon. Well, since it's regular, let's think about what that means. Regular. Well, all sides will be equal and all angles will be equal. So I know this is an equilateral triangle, so I know that this side will be 24.2 feet and the base will be 24.2 feet. So let's start using our formula. Area is equal to 1/2 times the apothem, which is 7, times the perimeter. All I have to do is add up all the sides together, and I get 72.6. In order to find the area, I just multiply all of these numbers together. 1/2 times 7 is 3.5. 3.5 times 72.6 is equal to 254.1 feet squared. Go ahead and pause the video and go and solve number 2. When you come back, the answer will be written. So you should have got the area of that regular octagon to be 851.2 centimeters squared. So let's talk about what if we're not given an apothem or we're not given a side length. So let's scroll on down. My first step is to create a right triangle by drawing the apothem and radius. Well, they already drew the apothem for me. Let's draw the radius. Step 2 is to find the measure of the interior angles where the radius intersects the vertex. Remember, in a past unit, we found what each angle is in a regular, polygon. And that formula is this, but there is a typo. The sum of the angles in a regular polygon is equal to n-2 times 180 degrees. So go ahead and fix that to a times. So let's find the total degree amount inside a regular hexagon. That's equal to n-2. N stands for the number of sides you have. So in this case, it's a hexagon, so you have 6 sides, minus 2, and we multiply that with 180. So that is equal to a grand total of 720. Now, the next part of this step, it says to divide by n. And the reason I'm doing that is to get each individual angle. So each individual angle in a hexagon is 720 divided by 6, which is equal to 120. So each one of these angles is 120 degrees. The next step after that, it says to divide by 2. And the reason I'm doing that is so that I can get this inside angle here in my right triangle. And I'm just going to go on to the next page and make that right triangle a little bit bigger so we can see what's going on. We said that the apothem is 5, so I'll label that 5. And we know that each angle in that hexagon is 120. So this would be the side to the hexagon. We know this whole thing is 120, so we divide that by 2, and each one of those angles is 60. So a 60 there and a 60 here. Well, this is a special right triangle now. We have a 60-degree angle, a 90-degree angle that forces the third angle to be 30 degrees. A special right triangle. Well, that will end up helping us a lot. We are trying to find the area of this regular hexagon. The area is equal to 1/2 times the apothem, which we already know is 5, but it's also times the perimeter of that hexagon. Well, we need to find this side here, which I'll call x. And remember, that's exactly half of the entire length of the hexagon. So we'll label that x. Now, in order to find x, I use my properties of a special right triangle, and we have to remember what those are. In a 45, 45, 90 triangle, this side is going to be equal to this side. And remember, the hypotenuse of a 45, 45, 90 is radical 2 times x, the other side. In a 30, 60, 90 triangle, though, it goes a little different. The shortest side is what it is. The hypotenuse is twice the shortest side. And remember that the longer leg is s times radical 3. So we're going to use that in our special right triangle in our hexagon. So in my hexagon, it looks like the shortest side is 5. Well, in order to get back to the, the shortest side is not 5. The longest side is 5. The shortest side is x. So instead of multiplying by square root of 3 to get to the longer side, we have to end up dividing. So we have x is equal to 5 divided by radical 3. And that's approximately 2.89. You don't have to rationalize the denominator. It's okay to just round to the nearest hundredth or nearest tenth. So we found what x is, and that is just the little half part of the whole side of the hexagon, 2.89. In order to get the whole hexagon, I have to multiply that with 2. And then the perimeter of this whole thing will be this little chunk, the 2.89, times 2 to get the whole side, times another 6, because there's 6 sides. So the perimeter of the whole thing is going to be equal to 34.68. Now let's plug into our area formula. 1/2 times 5, the apothem times the perimeter, 34.68. And we get a grand total of 86.7 meters squared. Now I know that was like a lot of information to go through. So go ahead, pause the video, try number 4, then come back and I'll explain it. Okay, and I know there's a lot going on in this picture. I just blew it up and made it a little bit bigger. We know that the apothem is 18, so I already started my formula down here. Area is equal to 1/2 times 18. Now, I came over and drew this triangle on the right-hand side of my page here. I know that each one of these angles is 60 degrees because it's an equilateral triangle. That means that this angle here has to be 30, and this angle here has to be 30. So I labeled 30 in my right triangle. Now this is a special right triangle, and the 18 is the shortest side. So in order to get this side here, which is this one, which I need to be able to do 18 times radical 3, and that's approximately 31.2. So I labeled this side 31.2, this half is 31.2. You find the total for the whole side, and you multiply that with 3 to get the perimeter. So the perimeter, in this case, is 187.2. You multiply that with 1/2, and you multiply it with 18, you get a grand total of 1,684.8 millimeters squared. And it might be a little off depending on how you rounded. So let's go back to our main page here. And let's talk about something like number 5. In number 1 and number 2, we were given, number 3 and number 4, we were given special right triangles. They were both 30, 60, 90 right triangles. But in number 5, we won't have that. I first start by drawing my radius, and then step 2 says to find each interior angle. Well, it's a pentagon, so I know that each interior angle will be equal to 108. That means that each little part of the right triangle here, if this is 10, we know that this angle here won't be a special right triangle. Half of 108 is 54. So I can't use the special right triangle cases, but I can use SOHCAHTOA in order to solve for my missing side length. In this case, I'm just going to draw this a little bit bigger. The apothem is 10. We're looking for this side of the triangle, which we're going to call X. We know that this angle here was 54 degrees. So I can use, in this case, it looks like we're using the opposite side, which is 10, and the adjacent side, which is X. That's a tangent function. All right, so we start by using the tangent of 54, because that's my angle that I'm working with. It's equal to the opposite, so 10 over the adjacent. Hopefully you remember how to solve these types of problems, but if not, I'll go through it. You have to get X out of the bottom, X out of the bottom. You have X tangent of 54 is equal to 10. You have to solve for X, so you go through and divide by tangent of 54 on both sides. And you're left with X equaling 10 over tangent 54. Remember to put your calculator in degree mode. Make sure it's in degree mode, or else it will not give you an accurate answer. So when I go and type that in, it is approximately 7.27. The last step is to actually find my area, which we know is equal to 1/2 times the apothem, which is 10, times the perimeter. Well, we know that each little chunk here is 7.27. So I double that to get the whole length of the whole side, and then I multiply that number with 5 to get the whole perimeter, which is 72.7. So we know the area is equal to 363.5 inches squared. All right, so go ahead and try the rest of the problems number 6 on the front page, and number 7, 8, 9, 10, 11, 12, 13, 14 on the back. If you can use the special right triangle properties, try to use them. If not, then use SOHCAHTOA in order to solve for the side length or the radius. Now pause the video, and when you come back, all of the answers will be up for 6, 7, 8, 9, and 10, 11, and 12, and 13, and 14. So here's the answer for number 6. Flip to the back. The answer for number 7 and 8, 9, 10, 11, and 12, and the answer for 13 and 14. So come in with any questions next class, and we'll talk about it.